Assalamu alaikum warahmatullahi wabarakatuh. I hope you have seen the previous lecture. So far, we have discussed data storage and the representation of different file formats such as text, such as images, and sound, that how a computer interprets these files or stores these files in binary language. Now, our next subtopic of data representation is data compression. So let's have a look at what compression is. Compression is the process of reducing the size of a digital file. It may be an image file, it may be a text file, a .docs file, a .ppt or present PowerPoint file, it may be an Excel file, or it may be a movie file. Regardless of whatever type of file it is, as long as it is a digital file, then the process of compression means they're trying to reduce or actually reducing its size. It is done for following benefits: in order to take up less storage on the hard drive, to use less bandwidth when uploading or downloading the file, and to send the file faster, or you can also write this as to send the file in less time, and also to lower operational cost, especially when you are using cloud storage, because in cloud storage or online storages, the more GBs of data you store online, then the more you have to pay them annually or monthly, according to whatever type of subscription you have. Okay, there are two types of compression: lossy and lossless. Each method reduces the number of bits in a file or reduces the file size, but they both have a different approach to it. Lossy file compression removes the unnecessarily bits from the file permanently. You can, if you transform or if you compress a file through lossy encryption, lossy file format or lossy algorithm, then you cannot get the original file back. It cannot be reconstructed. For example, you may convert a video file from any of the video format into MP3, but you would not be able to reconstruct the original file from the MP3. You cannot convert an MP3 file into a video file or MP4 file. It's not possible. Now we use lossy file compression when we are streaming videos online, such as on YouTube or any other movie websites. If you do not have a very good internet connection, or you are browsing the internet on data connection, then you can simply choose 720p or 360p instead of playing the video in 1080 HD. The second type of file compression is lossless file compression. In lossless file compression, file size is reduced by using different algorithms, and one of them, which is actually in your syllabus as well. It basically deletes the repeated words in a file temporarily, so that the file size can be reduced, as each character needs a memory space, so it just deletes the repeated words and stores them in code form. And when the file is uncompressed or the user wants the original file back, then those words are put back into the file. So in this way, no data is lost while uncompressing the file. For example, it is used when you are sending code for a program, when you are downloading the installer file or the exe file from the internet for a software, and so on. Because when if you are downloading the code for our software, the installer file, or if you're downloading a script for the internet, if you use lossy compression and part of the code is deleted forever, then that code would not be able to work on your computer. You need all the bits in order for the software or the code to run. Now there are a few file formats which you should know. There are three file formats for lossy compression and one file format for the lossless compression. So let's have a look at them. The first one is the MP3 file format. These are audio files which use audio compression to remove the sound that are beyond or on the boundaries of human audible range, hence compressing the file size for up to 90%. What the MP3 file does, it first of all it deletes or discards all the data related to the pictures or images or animations or video. The second thing it does, it uses a technique that is known as perpetual sound shaping. What is the meaning of perpetual sound shaping? That if two sounds are being played simultaneously, means if two sounds are being played together, then your human then your ears, the human ears, they can only perceive the louder sound and they would not be able to recognize the softer sound. So MP3 file format at such places completely removes the data for the softer sound because it would not be hearable by humans anyway. And when it does that repeatedly, the overall file size is reduced. This is known as perpetual sound shaping. So if the examiner asks you about MP3 file format, then you have to mention this perpetual sound shaping as well as the part that they remove the sound that are beyond or on the boundaries of human audible range. And next thing, it can compress the file size for up to 90%. For example, if you have an MP4 file of let's say 100 MBs and you convert it into MP3, then the file size for the newly made MP3 file would just be around 9 or 10 MBs. The next format which we have is MP4 format, and it is a standard for viewing videos online. It allows the storage of images, videos, and animations. Okay, it reduces quality in order to save up bandwidth when streaming videos online. Like you can easily confirm that if you get a DVD of a movie from the market, then the DVD is going to be somewhere about from 2.5 GBs to something like 3 GBs or more. Whereas if you browse the same movie over the internet, or if you download it in MP4 from the internet, then you would see the file size is just 600 to 800 MBs. So MP3 basically reduces the screenplay quality so that the file size can be reduced, whereas it tries its best to mimic the original quality so that the user does not feel much of a difference or much of a drop in the quality. The next is an image format, that is a JPEG or JPG format. It stands for Joint Photographic Experts Group. It is an image format that is used to reduce file size of images. As I told you before as well, that if you have a DSLR camera and you click an image from that, then that is a raw file. And a raw file means that it is not processed and it contains all of the information about each and every shade of color in the picture. Raw files are anywhere from 25 MB to 50 MB per file, whereas if you convert them in JPEG, then the file size can be reduced by 5 to 15%. The new file size would be anywhere between 5 MB to 8 MB. Now, what the JPEG or JPG format does, as we when we were discussing pixels, we saw that there can be the pixels can represent about 16 million colors. The human eyes cannot perceive that many colors, or it cannot differentiate between shades of so many colors. The human eye can hardly recognize about 1600 colors. Even if you have very exceptional eyes, you still would not be able to identify more than 2200 or 3000 colors. Now, what about the other colors out of 16 million? So, what you can do is, so what the JPG does, that it completely deletes information about those shades of colors which the human eye cannot perceive or cannot distinguish. Like there may be around 4 million different shades of red, but you cannot differentiate between them because human eyes are not that much capable. So for the few hundred shades of red which the human eyes can recognize, JPG is going to leave intact, whereas the other uh, millions of shades of red which the human eye cannot differentiate, the JPG format would simply delete it or convert it into simple red. So overall, you would feel like that the image quality is the same, but on the background, the information for all of the colors which you cannot see is deleted. So since a lot of bits are deleted in this process, the file size reduces exponentially. Then there is some detail about it which you can read, that how it works. It works by discarding shades of color which can't be or barely can be recognized by human eye. By separating pixel colors from brightness, images can be split into 8 by 8 pixel blocks, which then allows certain information to be discarded from the image without causing any real noticeable deterioration in the quality. You cannot basically tell the difference that the quality has been dropped, but for the computer, the quality or the file size has been dropped exponentially. Next, we have lossless compression, and for that, there can be two things. One is zipping the file, and the other one is a run length encoding. RLE is in your syllabus, but I'm going to show you the zip process anyways. Let's suppose I have this file over here. This is 11.6 kbs. This is a MS Word file. Now, if I made a zip out of it like this, now this was 11.6 kb, whereas this one is just 9.2 kb. So you can see the file size has been reduced. Now, even if I delete the original file, when I uncompress it, I'll get exactly the same file back. This is this is the file I just uncompressed, and see, it is back to 11.6 kbs. The So if the examiner asks you for a file format that is that uses lossless compression, you can write a .zip or a .rar file format, or you can write a WinZip or WinRAR. That would be acceptable. Now, the part which or the type of lossless compression that is a part of your syllabus, that is RLE, run length encoding. It can be used for lossless compression for a number of file formats, for example, text files, for example, image files, and so on. Now, how it works is that it reduces the size of a string of adjacent data, for example, repeated words or repeated colors in an image. A repeating string is encoded into two values. The first value represents the number of identical data items, and the next value represents the value the value of the repeating character in ASCII. RLE is only effective when there is a long run of repeated units or bits. For example, I know it may be difficult for you to understand, so let's have a look at an example so you can understand it better. Using RLE on text data, let's suppose you have this string. Okay? You have about 6 A's, 4 B's, you have 4 A's, 6 B's, and 3 C's. Okay? Now, if, as we have read in ASCII, that a one character takes about 1 byte, so that means this whole string is going to take about 13 bytes. Now, using RLE, this can be encoded into how many A's do we have? 4. So we are going to write 4, and what the value, and it is would be followed by the value of small a in ASCII, that is 97. So the code for this part would be 0497. Next we have 6 B's. So we are going to write 06, and the code for B in ASCII is 98. So it is there. And then we have C, whose value is 99, and there are 3 C's, so we write it as 0399. Now each RLE code requires 2 bytes. 1 byte for this part, that what was the number of repeating characters, and 1 byte for the ASCII code. So 2, 4, and 6. Now this code is only going to take 6 bytes, whereas this one would require 13 bytes. So as you can see, using RLE on text data has means that you have reduced the file size by almost 50%, in fact more than 50%. Similarly, if we use RLE on images, This how it compresses the size of an image is that it group together repeating pixels and store how many times they occur. For example, this is a sample picture, and this picture is a grid of 9 by 10 pixels. This is this small square box depicts 1 pixel. So there are 9 tens are 90 pixels, and if each pixels take 3 bytes, since this is a colored picture, then you are going to need 270 kbs for storing this file. Now, how RLE calculates its compressed file is that it counts how many pixels of the same color occur together. For example, the image starts with white pixels. So it is going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is going to write the first code as 12W, means 12 whites. Next, it has 1, 2, 3 yellows. So it is going to write 3Y, Y for yellow. And next we have 1, 2, 3, 4, 5, 5 whites, 5 whites, and so on. The complete code is given on the next slide as well. See, this would be the compressed code for this image over here. And the new file size would only be 58 bytes because there are 29 pairs now available, 1, 2, 3, 4, and so on. These are 29 pairs, and since one pair is of 2 bytes as we discussed above, so this code is only going to take 58 bytes, or this compression would only take 58 bytes, whereas the actual file is going to take 270 bytes. It is almost 1/4 of the actual file size. I hope you have understood the topic. Please feel free to contact me if you have any problem. Next, we are going to have a few practice questions. An MP3 file compression reduces the size of a music file by 90%. A music track is 80 MB in size. Calculate the file size after compression. You simply, if the original file is of 80 MB, then the after conversion to MP3, 90% would be reduced. So that means about 8 MB would be left. How many MP3 files of the size calculated above could be stored on an 800 MB CD? If one file is of 8 MB, then on 800 MB you can store 100 files. Explain how MP3 file retains most of the original music quality. Over here you'll talk about perpetual sound shaping, and you will also tell that it discards all the sounds which cannot be heard by human ear or which are outside the audible range of a human ear, and you'll get your both marks. State the type of file compression used in MP3, that is lossy. Name another file compression. That means you have to give an example of lossless file formats. They can be WinZip, they can be GIF or GIF, they can be yeah, zip, rar, GIF. You can write these. Then there is another question. Gurdeep wants to send a large file to Jennifer. State two benefits of compressing the file. Two benefits: saves time. It is easy to upload and download. Um, the file would be sent quickly. You can write any one of these, any two of these, because this is a 2 mark question. Two types of compression are lossy and lossless. Choose the most suitable type of compression. Downloading the code for a program, you are going to need lossless compression for that. And the reason you are going to write is because if any of the bits of the program codes are lost, then you would not be able to run the program on your PC. Streaming a video file, for that you can use lossy file compression. You can stream the video online on MP3 file format. It would reduce the quality, but it would still be enough to enjoy the movie. If you cannot get the answers on your own, then there are answers on slide number 11 and 12 as well. You can verify yours from them, or you may use these as guiding points to write your answers. Next, we have two questions. You guys are going to solve two questions as assignment. One is related to In fact, both of them are related to compression. Okay, so I want you guys to give the heading of data compression, and afterwards solve these two practice questions in your copy, and afterwards solve these two assignment questions in your copy. Okay, if you have any problem, feel free to ask me. Take care. Allah Hafiz.